So we stopped here, but just to summarize, we get the volume of encroachable water from this equation. The bigger it is, more support. But on top of that, there is also the aquifer productivity index. The larger it is, the faster will be the rate of the fluid, which is water, from the aquifer into the reservoir. And so those two things play a major role in the Fetkovich aquifer model. And feel free to read this, which is from your technical documentation, and that's pretty much similar to the version of the equation presented in the previous slide. So very important is the aquifer productivity index and initial amount of encroachable water. And like I said, the behavior of the pressure decline early in the life of the well is most strongly influenced by the productivity index, right? If the water is able to make it into the reservoir quickly, then you can support the pressure and the pressure will not decline as much. So when you see a steep decline like you have here, then the aquifer productivity index is actually low. And then the initial amount of encroachable water, WEI, controls the level at which the flowing bottom hole pressure flattens out at. So if it flattens out at a high value, then you can conclude the WEI value is high. If the WEI value is low, then it's going to flatten to a very low flowing bottom hole pressure, even if aquifer PI is large, because there's just not enough volume of water to keep or maintain the pressure in the reservoir. Again, feel free to read up all of this in your IMEX manual. And there are different aquifer models. You use the keyword aquifer to specify the aquifer, and then you will realize you get to choose the aquifer model you want. There is the option to choose the regions to be affected by the aquifer, and that's the default option. You can also model your aquifer using Builder. So if you go to the reservoir section of the CMG Builder, and you double click on that, you will see aquifer. And then you double click on aquifer and you can set up your aquifer in that mode. Again, like I said, the region is the one that we typically use. That's the default option. That's what you'll be using in your project. And you have two options: to work either in Builder or to simply modify the data input file. And so you can provide parameters such as initial pressure of the aquifer, viscosity of the aquifer, and the next couple of slides are just taken up from the IMEX manual, which you can read directly from the IMEX manual. This is the aquifer model we will be using, and then you can adjust the parameters of this aquifer model until you're able to match the flowing bottom hole pressure given. So what do you think AQPI will mean? Aquifer Productivity Index, aquifer PI. About VI, that's the WEI, initial volume of encroachable water. And there could be some unit issues which Dr. Hughes pointed out in the previous class. It appears the version of CMG you guys are using, which I believe is 2019, might show this as barrels, whereas internally CMG is using cubic meter. So actually cubic feet, this second unit right here. So just ignore that. The actual values don't mean much, is the magnitude. So you just need to find out what magnitude you need for these two guys to match your flowing bottom hole pressure. These are some other parameters that can be changed to match your history. But in the Fedkovich model, by far, what you need is just J for the aquifer and WEI, and you will be able to match whatever flowing bottom hole pressures. And so I'll skip the remaining slides because you can feel free to read those in your IMEX manual. And that's pretty much how we model aquifers. They help match the flowing bottom hole pressures in your reservoir. We previously talked about set PI. So you can also set the productivity index to a specific value. The focus here is on well PI, which we discussed previously, right? You can set the productivity index for these different phases. And I already explained this. This is an example input file, 2 wells, and here you're setting the a PI multiplier. You're basically multiplying the PI for the oil phase by 1, so you're leaving it unchanged, and you're doing that for the 2 wells. When you use mult star, you're multiplying the PI for all of the wells by this value, which is 2.3. And that's pretty much the end of this module.